Good day viewers, you're welcome once again to another interesting tutorial time with Jot Tutors. And today, very quickly, we are going to look at Euclidean Geometry. Please, we encourage our viewers to like our videos, share it, and please subscribe on our YouTube channel. Very quickly, we want to look at the summary of circle theorem. There are many, they are numerous. But we are just going to pick some of them as a reminder, like a summary of some of the things we have learned. And if you have not learned it in school, please, it's an avenue for you to know about them. And after this summary, we're going to go into some questions to look at the application of the theorem. All right. The first theorem tells us that perpendicular from center bisects the chord. Bisects the chord. Perpendicular line from circle center bisects a chord. Perpendicular line from the circle center bisects a chord. Number two, we have perpendicular bisect through center, which means the perpendicular bisector of chord passes through the circle center. Perpendicular bisector through the circle. These are just the summary of those circle theorem. Another one says angle subtended by an arc at the center is twice angle subtended by the same arc at the circumference. In summary, we can write it as angle at center is equal to twice angle at circumference. Okay, in short form. All right, another theorem tells us that opposite angle in a cyclic chord are supplementary. Opposite angle in a cyclic chord are supplementary. Okay, these are just a summary. We are going to look at the application of all this circle theorem later on. There is another one who tells us that angle in same segment they are equal. They are always equal. Angle in same segment are always equal. I just put it equal. Just put it into bracket. Okay. Let's look at another one, which tells us that the angle between a tangent to a circle and a chord drawn at the point of contact is equal to the angle which the chord sustained in the alternate segment. This theorem is called the tan chord theorem. Please, you can check your textbook for all the details of this theorem, but we are only highlighting them just as a reminder before we go into the application of the circle theorem. Now let's go into some application. Let's see some questions that we can use some of this theorem to calculate. All right, so let's go into some questions under the Euclidean geometry. The question says AO is parallel to CB. We can see this. The parallel line indication is shown in the circle with center O. So this is the center of the circle. And they said AOB, angle at O, is 70. We can see it to be 70. Then we are asked to calculate angle Y and angle X. We are asked to calculate angle y and angle x. Now we should note something. Anytime we are solving questions under Euclidean geometry, you must give a reason why your answer is going to be like that. And those reasons are gotten from the theorem that we have actually highlighted. Not all the theorems were initially discussed. I've told us we have numerous theorems, but we actually summarize some of them that are very, very, very important to questions like this. All right, so let's look at this. If we look at y, the angle at y ACB, ACB is subtended to the same angle as AOB. If we look at it, subtended by the same arc. This is the arc. Dotted line show actually the arc of the circle. So it is subtended by the same arc. So that means my angle at y, which is the ACB, angle at C, angle y, which is the ACB, is the same thing as the angle at the circumference to the angle at the center. And remember, one of the theorems states that the angle at the center is twice angle at the circumference. So my angle y, which is the angle ACB, is going to be 70 over 2, which is 35, and the reason is angle at center equals 2 angle at circumference. Please note this. All right. Please, the reason why it is like that is because they are subtended by the same arc. Please don't forget they are subtended by the same arc. We are still going to look at so many questions under this Euclidean geometry. Now the second question says angle x. Yes, we have actually gotten angle y. We can look for angle x. My angle at x, angle x, is the same thing as my angle y, and the reason is that alternate angles are equal. Alternate angles are equal. That is all. Very simple. You see, this is the straight line, the parallel lines, and this is the line cutting the parallel line. So whatever we have in y will be equal to what we have in x. Alternate angles are equal. All right, that is for that on this question. And let's look at another question. All right, this is another question. And the question says D, E, F, and G are points on circle with center M. We can see the center M. And F1, angle F1 is 7. This is F1. So let's put our 7 there, 7 degree. This angle is 7 degree. And D2, angle D2, you can see D2 around here is 51. So let's also put that one there, 51 degree. All right. Now the question now says determine the sizes of M1, angle D1, F2, angle G, and also E1. All right, let's take them one by one very quickly. Remember, I have told us that anytime we are solving Euclidean geometry questions, always give your reasons for your answers. And your reasons comes from the theorems, or the theorems that you have identified when we started. All right, so M1, if we look at M1, we're looking for M1, we're looking for this angle, we're looking for M1. All right, first and foremost, we can look for E2. We can look for E2 because E2 is also very related to D2. E2 is related to D2 because of what? Because they are subtended by the same arc. If you look at it, they are subtended by the same arc. An angle in the same segment subtended by the same arc or chord are equal. So that means my E2 is equal to D2, which is 51. And I put my reasons, angle in same segment. All right. Okay, we are not done yet. So now, if I know my angle at E2 to be 51, and I'm looking for M1, definitely my E2 is the same thing as my F2. Why do I say that? Because it's an isosceles. It's an isosceles triangle. Look at this. This is a radius. This is a radius. This is a radius. This is another radius. So the same line will sustain the same angle. So definitely my E2 is equal to F2. F2, which is 51, and the reason is isosceles triangle. Let's just put it like that. Isosceles triangle. All right. Now for my M1, the total angle in a triangle is what? Is 180. Is 180. So if I have this one as 51 and I have this one as 51, if I subtract it from 180, definitely my M1 is going to be 78. Angle in a triangle. Sorry, please, because of the space. Angle in a triangle. Okay, I hope we are cleared with that. Okay, so let's go to D1. Let's go to D1. D1, yes. Now, if we look at the diagram, this is the diameter of the circle because it passes through the center. And one of the theorem tells us that angle in a semicircle is a right angle triangle. So more or less, this is a semicircle. EDG is a semicircle. So EDG is a semicircle. So if it is a semicircle, definitely this place should be 90. And part of the 90 we already know 51 as part of it. So definitely the D1 is going to be 90 minus 51. 90 degree minus 51, and it's going to be what? It's going to be 39 degree. Very simple. EDG, angle at D, is a semicircle. So definitely we know that at D it should be 90. This should be 90 according to the theorem of circle. Okay, that is settled. For F2, we have already done something like that from the first question. So my F2 is the same thing as 51, which is an isosceles triangle. It's an isosceles triangle. So that is the reason. I've always said this, that please, when you are answering Euclidean geometry, you must state your reason, and it's one of the easiest topic you can deal with in mathematics. All right, for G, let's now for G, if we look at the diagram very well, we will see that G is in the same segment with F1 and F2 equals to G. F1 plus F2 equals to G. We should know that because they are in the same segment, subtended by the same chord. Do we see that? That's a chord subtended by the same chord. They are also subtended by the same arc. So my F, and I know my F2 to be 51. So my G is going to be 51 plus 7. And 51 plus 7 will be 58 degree. We put the reason as angle in same segment. All right, I think that is settled. And the last question that we have under this is E1. Now that I know my G and I know this side, my E1 will be very easy to determine. We should know that the total angle in a triangle is 180. So if I have 180 minus 90 minus 58, then I'm going to have 32. E is going to be 32 degree. Total angle in a triangle. Total angle in a triangle. Most of the time when we are solving these questions, it is good to abbreviate. But if you know you are not going to be very good in abbreviation, you can still state your reasons out. You can state it out. You are still going to get your full max. Please watch out for our subsequent videos on Euclidean Geometry. We're going to deal with so many questions, difficult questions, tactical questions, challenging questions, and I'm very sure the learners, whether you're in year 11, year 12, or year 13 or thereabout, you will find it very, very helpful and useful. So thank you so much for watching our video. Please subscribe and please share with your friends. See you next time.